So let's go ahead and let's use our skills, our knowledge of redox reactions, the definition of oxidation, reduction, oxidizing agent, and reducing agent. Let's use our skills regarding those and the rules for determining oxidation numbers or charges for a particular species. We're going to do these examples with regards to the oxidation number of sulfur in a second, but let's revisit this equation that we introduced, gosh, was it 2 slides or 2 videos ago. If I gave you this combination reaction, this balanced combination reaction of solid calcium reacting with oxygen gas to give me calcium oxide, and if I was to ask you what's being oxidized and reduced and what the respective oxidizing and reducing agents are, to answer that question, you need to get your pen and you need to know the charges or the oxidation numbers for the reactants and products. And as we talked about in the last video, the rules for elements that are by themselves, not in an ionic compound, those oxidation numbers, those charges are a big fat 0. So both calcium and oxygen as reactants have charges or oxidation numbers of 0. As a product, both calcium and oxygen are bound together as an ionic compound, and so the charges on them will equal what the charge of their monoatomic ion is that we learned in Unit 1. So that calcium, which is in group 2, is a +2. Oxygen, which is in group 6, -2. And so knowing that from those rules and remembering that Leo goes Gur, or if you prefer oil rig, whichever mnemonic you like, you should be able to determine that calcium, which went from a 0 to a +2, became more positive, so it lost electrons. And so what is being oxidized is the calcium. Oxygen, which goes from a 0 to a -2 in this equation, became more negative, so it gained electrons. So what is being reduced is the O2. So that's determining what is being oxidized and what is being reduced. And remembering that the oxidizing agent is the species that is reduced. Oxygen is also the oxidizing agent. And the reducing agent, that is the species that is oxidized, that is the calcium. So that's how to attack this problem using those concepts of oxidation reduction and oxidation numbers. Now let's practice a little bit more the rules of determining oxidation numbers of particularly the sulfur in these 5 compounds by using the oxidation number rules we discussed in the previous video. So looking at this first molecule, H2S, hydrosulfuric acid, I know that the charge on 2 of the hydrogens plus 1 sulfur must be 0. The sum of the charges of a neutral compound has to be 0. Hydrogen, since it's bound to a nonmetal, that hydrogen is +1, and there's 2 of them, so that part of the molecule is a +2. So the only way that overall charge on this molecule can be 0 is if sulfur is a -2. So in this first compound, hydrosulfuric acid, sulfur is a -2. In this next compound, we have sulfur all by itself as an element bound to 8 other sulfurs. But the charge on any element by itself is a great big fat 0, so that means sulfur in that S8 compound is 0. Now we've got sulfur bound with chlorine. And remember that chlorine, halogen, it's -1. There's 2 of them, so that part of the molecule is a -2. So for the charge of the overall molecule to be 0, that sulfur in SCl2 must be +2. 2 more to go, sodium sulfite. So we have to, before we can determine the charge or the oxidation number on sulfur, we need to know the charge for 3 oxygens and 2 sodiums. So sodium, monoatomic ion, so sodium is a +1, and there's 2 of them. So that part of the molecule, the Na2, contributes a +2. Oxygen, oxygen's bound with the sulfur and the sodium. Oxygen is always a -2, unless it's hydrogen peroxide, then it's a -1. There's 3 of them, so that part of the molecule is a -6. If I can draw that correctly, sorry, -6. So I have +2, -6. For the sum of my charges to equal 0, that must mean my sulfur is a +4, because +2 +4 -6 equals 0. So in this last species, the sulfate polyatomic anion, in this case, the sum of the charges is not going to equal 0, but will equal -2. So I look at oxygen, which I know is a -2 since it's in group 6. There's 4 of them. So 4 times -2 is a -8. So the charge on sulfur plus -8 must equal -2. So that means the charge on sulfur in this molecule is a +6. And again, the reason why we determine oxidation numbers is because that will help us determine in redox reactions if a particular species is being oxidized or reduced, kind of like what we had needed to do over here with the calcium and the oxygen. So for the exam, you should feel comfortable using those oxidation number rules to determine oxidation states of particular atoms in a molecule. And using that information along with the definitions of oxidation reduction, oxidizing agent, and reducing agent to answer questions like what we did over here with the calcium oxide reaction. And so that is the end of our discussion with regards of types of chemical reactions. In the next videos for this chapter, we're going to revisit solutions. We talked about solutions with regards to solubility in double displacement precipitation reactions. We're going to revisit the concept of solutions and how to calculate concentrations of solutes in solutions, and then use that information to do stoichiometry problems that involve titration. Those topics will be the next subjects of our subsequent videos.